Hey kids, welcome to section 4.3, dividing polynomials. Today we're going to learn how to divide polynomials using long division and how to divide polynomials using synthetic division. So first we're going to talk about a polynomial divided by a monomial. You have done something similar to this before. So if we look at part A, the directions say simplify. So we're going to take each of the terms in the numerator and divide it by the monomial in the denominator. So we're going to have 6x to the fourth y cubed, put it over the denominator 3xy, plus 12x cubed y squared divided by 3xy, minus 18x squared y divided by 3xy. So take each term in the numerator and divide it by the denominator. Then we're going to simplify. So if we take a look at this first term, I can do 6 divided by 3 and get 2. I have x to the fourth over x to the first, that's x to the third. And I have y cubed over y, that's y squared. Plus, then if I took a look, 12 divided by 3 is 4. Then I have x cubed divided by x, which is x squared. And I have y squared divided by y, which is y. Minus, here I have 18 divided by 3, which is 6. I have x squared divided by x, which is x. And y divided by y goes to 1. Check and see if you've got any like terms. If you do, collect them. If you don't, move on. Okay, if we take a look at letter B, we have a trinomial divided by a monomial. It looks a little bit different than the setup for B. However, they're the exact same thing. So what we're going to do is take each of the terms in the trinomial and divide it by the monomial. So we're going to take the first term, 20c to the fourth d squared f, and we're going to divide it by 4c df. Minus, take the second term, 16c df squared, and divide it by the monomial 4c df. Then we're going to take the next term, 4c df, and we're going to divide it by 4c df. Then we're going to simplify all this. So if we take a look at the first term, we got 20 divided by 4, which is 5. We got c to the fourth over c to the first, that's c cubed. We have c squared, or d squared, divided by d, which is d to the first. And we have f divided by f, that goes to 1. Minus, now I have 16 divided by 4, which is 4. I have c divided by c goes to 1. D divided by d goes to 1. F squared divided by f, that goes to just f. Plus, I have 4 divided by 4 is 1. I have c divided by c is 1, d divided by d is 1, f divided by f is 1, so I have a plus 1. It's very tempting to forget the 1 at the end, but remember, this is a fraction, has the same thing top and bottom, so I need a number that shows it's simplified. All right, finally, letter C looks completely different than A and B. However, it is the exact same thing. Remember, this 3xy to the negative first power, I can write that as 1 over 3xy to the first power. That's how negative exponents work. So technically, we have this binomial times this fraction, which is really the same as division. So we're going to take each of the terms in the binomial and divide it by 3xy. So 18x squared y divided by 3xy plus 27x cubed y squared z divided by 3xy. Now we're going to simplify this. So I have 18 divided by 3, that's 6. I have x squared divided by x, which is x. And I have y divided by y, which is 1. Plus, then I have 27 divided by 3, which is 9. I have x cubed divided by x, which is x squared. I have y cubed, or y squared divided by y, which is y. And I have a lonely z. No like terms, nothing to smush together. Okay, so this is what happens when you divide a polynomial by a monomial. Let's see what happens if we do a trinomial divided by a linear binomial. Well, the directions say to use long division to find each quotient. So we're going to do long division. Now, if you don't remember how to do long division, we could do like 329 and we could divide it by 4. And let's see, 4 goes into 32 8 times. 8 times 4 is 32. Draw your line, change your sign so you get 0, and then you bring down this 9, and then you say, oh, 4 goes into 9 2 times, and you multiply 2 times 4 is 8, and you add, change your sign, and you get a remainder of 1. So you say, and 1/4. Well, we're going to do the same thing, except we're going to do it with letters. So the first thing is a trinomial divided by a linear binomial. So we're going to take x squared plus 7x minus 30, and we're going to put it underneath the division sign, and we're going to put x minus 3 on the outside. Now you should only be worried about what is the first thing of each thing, lack of better word, sorry. So x is going to go times what to get x squared? And the answer is x. And we're going to make sure that we keep all of our like terms vertically stacked. So since it's an x as my answer, I'm going to put it over the other x. I wouldn't put it over the x squared or the number. Once I put that x up top, I'm going to distribute it to the x and the -3. So I'm going to say x times x is x squared, and x times -3 is -3x. Then I'm going to draw my line, and I'm going to change my signs or subtract. And when I subtract, I'm going to distribute. Now I'm going to add these together to get 0, and I'm going to do 7x plus 3x is 10x. And then I bring down the -30. Then I look again only at the beginning things. And so x goes into 10x 10 times. So I'm going to put a plus 10. And then I'm going to distribute. 10 times x is 10x. 10 times -3 is -30. I'm going to draw my line, and I'm going to change my signs, which is the same as subtracting them and distributing at the same time. So when I add, I get 0, and I add, I get 0. That means there is no remainder. So my answer is going to be x plus 10. So if I have a number left over, we're going to see that in a little bit. But you can also notice that x minus 3 times x plus 10, if I double distribute that and collect like terms, I get the trinomial back again. So something to notice. All right, if we take a look at B, we're going to put x squared minus 13x plus 12 underneath the division, and x minus 1 is outside. So again, we're only looking at the beginning things. So what do you multiply x by to get x squared? And that's x, so you put it above the other x. Then you distribute. X times x is x squared. X times -1 is -x. Then you draw your line, and you change your signs, and you add, and you get -12x, and you bring down the plus 12. Then again, you only look at the beginning thing. So what do you multiply x by to get -12x? The answer is -12. So then you multiply. -12 times x is -12x. And -12 times -1 is a positive 12. And you draw your line, and you change your signs. So this now becomes a minus. And then you add, and you add, and you get 0. So the answer is x minus 12. Again, if you multiplied the x minus 1 and the x minus 12, you should get the trinomial back again. All right, so let's change the format a little, and notice for letter A in this one, the directions still say to use long division to find the quotient, but I'm going to mix it up a little bit in terms of what you're dividing. So if you look at letter A, I have a cubed plus 2a squared plus 4a minus 9. And notice I'm dividing by 2 minus a. So if you want to, you can rearrange that and get negative a plus 2. And that makes it a little bit easier to divide by. So I can do a cubed plus 2a squared plus 4a minus 9. And I'm going to divide by a negative a plus 2. Okay, so we did that because we want to only look at the beginning things. So negative a times what is a cubed? And the answer is negative a squared. Notice I put it above the other a squared. Then I multiply. So negative a squared times negative a is a cubed. Negative a squared times 2 is negative 2a squared. Draw your line, change your signs, add. You get 0a cubed, 4a squared, and then bring down the plus 4a. Then you only look at the beginning stuff. Negative a times what is 4a squared? The answer is negative 4a. So then you distribute. Negative 4a times negative 1 is 4a squared. Negative 4a times 2 is negative 8a. Draw your line, change your signs, and add. You get 12a. Bring down the negative 9. Then again, only look at the beginning. Negative a times what is 12a? The answer is negative 12. So negative 12 times negative a is 12a. Negative 12 times 2 is negative 24. Draw your line, change your signs, you get 15. Ooh, so we have a remainder this time. So our answer is going to officially be negative a squared minus 4a minus 12 plus, and then whatever your remainder is, you're going to put over what you were dividing by. So I'm going to have 15 over negative a plus 2. And there is my answer. All right. Well, take a look at B. Notice that I have this negative 1 exponent thing again. Remember, that's the same as 1 over r squared minus 1. So technically, we are taking the cubic polynomial, and I'm going to divide it by this quantity over here. Now, it's okay that it's dividing by r squared. You can divide by powers. So I'm going to bring down the r cubed plus 6r squared minus r minus 4. And I'm dividing by r squared minus 1. So remember, I'm still looking at only the beginning things. I ask myself, r squared times what is r cubed? The answer is r. Notice I'm putting it above the other r. Then I distribute. R times r squared is r cubed. R times negative 1 is negative r. Look, I put it underneath the r. Draw your line, change your signs. I get 0r cubed. I got to bring down that 6r squared. I add to get 0r, and then I'm going to bring down the minus 4. So then I ask myself, r squared times what is 6r squared? The answer is 6, so plus 6. 6 times r squared is 6r squared. 6 times negative 1 is negative 6. Draw your line, change your signs, and add. We get 2. So that means my answer is going to be r plus 6 plus 2 over r squared minus 1. So taking that remainder and putting it in a fraction with the divisor. Okay, well, these get a little bit fun because they're more plentiful. So if we take a look, we have a cubic polynomial divided by a quadratic. So I'm going to put x cubed minus 2x squared minus 9x plus 18. And I'm going to divide it by x squared minus 5x plus 6. So it doesn't matter how many terms are in the polynomials that you are dividing by, you still concentrate on the very beginning ones. So ask yourself, x squared times what is x cubed? The answer is x, so we put it above the x. We distribute, x times x squared is x cubed. X times negative 5x is negative 5x squared. X times 6 is 6x. Draw your line, change your signs. Add, so you get 0, you get 3x squared, you get negative 15x, and we're bringing down the 18. So then ask yourself, x squared times what is 3x squared? The answer is 3, so we put a plus 3. Then I distribute, 3 times x squared is 3x squared. 3 times negative 5x is negative 15x. 3 times 6 is 18. Draw your line. Change your signs. So we add, we get 0, we get 0, we get 0. There's no remainder. So our answer is x plus 3. Now this next one is going to be a little tricky. When you are starting the problem, the first thing you should try to look for is to make sure that every exponent from the degree down is represented. Notice here that there is no x cubed. So we need to use a 0 as a placeholder when we are doing problems where one of the powers is not there. If you don't leave a space for it, it will throw off your answer. It doesn't matter if it's in the one you're dividing by, but it is important that it's in the one you're dividing into. So I'm going to put x to the fourth plus 0x cubed plus x squared minus 3x plus 5. And I am dividing by x squared plus 2. All right, only look at the beginning. So x squared times what is x to the fourth? The answer is x squared, so I'm going to put it above the other x squared. Then I'm going to distribute, so x squared times x squared is x to the fourth. And x squared times 2 is 2x squared. It's got to go underneath the other x squared. Draw your line, change your signs. The x to the fourth add 0. There is no x cubed. Then I add 1 and negative 2 to get negative x squared. Bring down the 3x. So then you ask yourself, x squared goes into negative x squared how many times? The answer is negative 1, so I put it over the 5. And then I multiply, negative 1 times x squared is negative x squared. Negative 1 times 2 is negative 2. Now, I'm pretty sure we're going to start to run out of letters that we can multiply, so we need to go ahead and also bring this 5 down. So now when we draw our line and change our signs, the x squareds add to 0. I bring down the 3x, and I have a plus 7. So my answer is going to be x squared minus 1 plus 3x plus 7 over x squared plus 2. So it looks a bit funky, but that is what it is. Okay, now these are all really nice when, long division always works. You can divide it with any type of polynomial. If you are dividing by a linear binomial, you can use something called synthetic division to go a little bit quicker. So synthetic division is just a simpler process for dividing a polynomial by a binomial. You definitely want this binomial to be linear. So we can't have any quadratics. We can't have anything higher than exponent of 1. When the polynomial and the dividend is missing a term, a 0 must be used to represent the missing term. We just talked about that on the previous slide. And these are the directions for synthetic division. It's not going to make much sense until I teach it to you, and then you can go back and read it if you want to summarize the process. So here's what synthetic division is. Synthetic division, like I said, is when you have a polynomial that you're dividing by a linear binomial. So what we're going to do is we're going to take just the coefficients, 2, 3, -4, and 15. And I'm going to write 2, 3, -4, and 15. Then I'm going to do this little L shape, and I'm going to leave room for another row of numbers underneath. Then I'm going to take a look at what I'm dividing by, and I'm going to set it equal to 0. And if I solve this equation by subtracting 3 to both sides, I get x equals -3. I'm going to take that number and I'm going to put it on the outside of this backwards division symbol. Then here's how synthetic division works. I'm going to take this 2 and I'm going to drop it down. So I'm going to put a 2. Then I'm going to multiply the -3 with the 2. And I'm going to put it underneath the 3 to get -6. Then I'm going to add 3 and -6 and get -3. Then I'm going to do the process again. I'm going to take the -3 and I'm going to times it by the -3 and I'm going to get 9. And then I'm going to add and I'm going to get 5. And then I'm going to do 5 times a -3 and I'm going to get a -15. And then I'm going to add to get 0. That 0 means that there's no remainder. And then I'm going to work backwards. This 5 is my constant. This -3 is my x to the first power. And this 2 is my quadratic term. So I've got 2x squared minus 3x plus 5. So synthetic division is really nice because there's no letters that you have to deal with. You're simply dealing with the numbers and then putting the letters back in afterwards. Okay, if we take a look at letter B, 3x cubed minus 8x squared plus 11 minus 14, and we're dividing by x minus 2. If I set that equal to 0, that means my x value is 2. So I'm going to grab my coefficients, 3, -8, 11, and -14, making sure that I have cubic, squared, first power, and no variable. Make my upside down division and put the 2 on the outside. Okay, so I'm going to bring down the 3. Then I'm going to multiply to get 6. Then I'm going to add to get -2. Then I'm going to multiply to get -4. Add to get 7. Multiply to get 14. Add to get 0. No remainder. The 7 is my constant. The -2 is my linear term. And the 3 is my quadratic. Also notice that if I'm taking a cubic and dividing it by a linear, 3 minus 1 is 2, so I'll have a quadratic left over. Look at letter A. I have a cubic divided by a linear. 3 minus 1 is 2. I have a quadratic left over. All right, let's take a look at some more. If we look at letter C, notice that there is no cubic term, so I need to put a cubic term in. So I'm going to grab the coefficients 4, 0, 2, -4, and 12. And on the outside, I'm going to pretend this equals 0, so I'm going to put a -2 on the outside. So then I'm going to bring down the 4. And then I'm going to multiply to get -8. And I'm going to add to get -8. And I'm going to multiply to get 16. And add to get 18. Multiply to get -36. Add to get -40. Ooh, this is getting big. Multiply to get 80, add to get 92. That 92, kids, is your remainder. So we're going to backtrack. The 92 is going to be put over what we divided by, but keep in mind it wasn't -2, it was a plus 2. And put a plus in front. My constant is -40. My linear term is 18x. My quadratic term is -8x squared. And my 4 is my cubic term. So 4x cubed minus 8x squared plus 18x minus 40. And you know what I just noticed? These are supposed to be a's. So 4a cubed minus 8a squared plus 18a minus 40. There we go. All right, if we look at letter D, I got 4, 3. Oh, no, square. So I need to put that square in. Grab the coefficients. 6, -8, 0, 12, -14. If I set this equal to 0, I'm putting a 2 on the outside. So we drop the 6, multiply to get 12, add to get 4, multiply to get 8, add to get 8, multiply to get 16, add to get 28, multiply to get 56, subtract to get 42. So this is my remainder, my constant, my linear, my quadratic, my cubic. 6x cubed plus 4x squared plus 8. These are b's. Make them b's. 6b cubed plus 4b squared plus 8b plus 28 plus my remainder 42 over b minus 2. All right, so what if we put a number in front of my linear term? So this time we have a polynomial divided by a linear binomial, but there is a 2 in front. Now, if you want to, you can use long division. If you don't want to, then we're going to learn how to do synthetic division still. Now, synthetic division only works if that number in front is a 1. It is not a 1, so we need to make it a 1. So we're going to divide that entire quantity by 2. And if I divide the second half by 2, I have to divide the first half by 2. So my problem becomes 4x to the fourth minus 2x squared plus a half x plus 2, all divided by x plus 1/2. Now that I have a coefficient in front of a 1, I can do my synthetic division. Notice also there's no cubic term, so I need to add a placeholder for the cubic term. So I'm going to put a 4, a 0, a -2, a 1/2, and a 2. Then when I synthetically divide, I'm going to pretend like this x plus a half equals 0. And so I have -1/2 on the outside. So I drop the 4. I multiply to get -2. I add to get -2. I multiply to get 1. I add to get -1. I multiply to get a half. I add to get 1. I multiply by a -1/2. And I add to get 1 1/2. So I have a 4x cubed minus 2x squared minus x plus 1 plus, now 1 1/2, you don't want to leave things with mixed numbers. So I'm going to rewrite that as 3 halves. So I'm going to put 3 halves over x plus a half. Now here's the thing. You're never allowed to have fractions within a fraction. So we need to get rid of the fractions down here in the denominator. So notice that both fractions have a 2 in the bottom. So if I multiply the top by 2 and I multiply the bottom by 2, I'm not changing the fraction in any way. I'm simply multiplying it by 1. So now I get 4x cubed minus 2x squared minus x plus 1 plus, now I just have 3 over 2x plus 1, which notice 2x plus 1 is what we divided by in the beginning. And yes, that should always happen. You should always get back again what you were dividing by. All right, let's take a look at letter B. Letter B, I have a fifth, a fourth, no third, so plus 0y cubed. A squared, no linear 0y to the first. And we're dividing by 4y minus 1. Well, I need to get rid of that 4 in front, so I need to divide by 4, and therefore divide the other side by 4. So that's going to give me 2y to the fifth minus 1 half y to the fourth. The 0y cubed, I don't really have to write, minus 4y squared plus 1, all divided by y minus a fourth. All right, so grab our coefficients, 2, negative 1 half, 0, negative 4, 0, and 1. And we're dividing by a positive 1/4. So we bring the 2 down, and we multiply 2 times a fourth to get a half, and we add to get 0, and we multiply to get 0, and we add to get 0, and we multiply to get 0, and we add to get negative 4, and we multiply to get negative 1, and we add to get negative 1, and we multiply to get 1/4, and we add, no, negative 1/4, and we add to get 3/4. If you don't like fractions, then use your calculator. Fractions are just numbers. All right, so we got our remainder, our constant, our linear, no quadratic, no cubic. So we have fourth power. These are y's. So I have 2y to the fourth minus 4y minus 1 plus 3/4 over y minus a fourth. Notice that my remainder has fractions. They're both 4s. So I'm going to multiply the whole thing by 4 over 4. That's going to give me 2y to the fourth minus 4y minus 1 plus 3 over 4y minus 1, which is what we want. All right, last examples. For letter C, we need to divide everything by 5 before we do anything. Also check your powers. I have 3, 2, 1, none, so I don't have to add any placeholders. So this becomes 3b cubed plus 8/5 b squared minus 21/5 b plus 6/5 divided by b minus 4/5. So as you can see, sometimes the fractions get a little funky, but you have a calculator, so it doesn't really matter. So we got a 3, we got an 8/5, we got a negative 21/5, and a 6/5. And we are dividing by a positive 4/5. Okay, so bring down your 3. Multiply, you get 12/5. Add, you get 20 fifths, or 4. Multiply to get 16 fifths. Add to get negative 5 fifths, or negative 1. Multiply to get negative 4 fifths. Add to get 2 fifths. So we have a remainder, a constant, a linear, and therefore a quadratic. So 3x squared plus 4x minus 1 plus 2 fifths over, oh, these are b's. This goes away, and this goes away. That was a 4b and a b. All right, 2 fifths over b minus 4 fifths. Multiply top and bottom by 5. So we get 3b squared plus 4b minus 1 plus 2 over 5b minus 4. Awesome. All right, last one. Take a look at what you're dividing into. All the powers are there. I need to divide everything by 3. So that's going to give me 2c cubed minus 17 thirds c squared plus 2c plus 8 thirds. And we're dividing by c minus 4 thirds. Grab your coefficients, 2, negative 17 thirds, 2, and 8 thirds. We are dividing by a positive 4 thirds. So we bring down the 2. We multiply to get 8 thirds. We add to get negative 9 thirds, or negative 3. We multiply to get 4, negative 4. We add to get negative 2. We multiply to get negative 8 thirds. We add to get 0. These are C's. I have no remainder. Constant, linear, quadratic. So 2c squared minus 3c minus 2. All right. That's it. If you guys have any questions, let me know. And as always, keep calm and keep trucking.